this video we are going to be, let me get my mimeopad working here, guys. We are going to be learning how to solve logarithmic equations, okay? Logarithmic equations, so obviously your heading will be solving logarithmic equations. This is our second video in lesson 8.6, so we're going to call this lesson 8.6 part 2. Be sure and include today's date. Alright, moving on. Now, remember in part 1 of lesson 8.6 we studied how to solve exponential equations. In my opinion, we got the tougher material out of the way. I believe solving logarithmic equations are much easier, okay? That's my opinion. Others might disagree. Here is what a logarithmic equation looks like, okay? You have a logarithmic equation when you have an unknown in the argument right here, or if you have an unknown for your base, something like that, okay? Now this technically is not a logarithmic equation in my opinion. Something like this, okay? But we are going to include those in our problems today, okay? To me, this is just basically solving a logarithm. Like if I give you this problem right here and I said solve that logarithm, you would set it equal to x and then solve it. But technically speaking, a logarithmic equation is when you have an equation and your argument has a variable. An argument is what you're taking the logarithm of. And in this problem here, we are taking the logarithm of x. So this is your argument right here. So whenever your argument has a variable, or when your base of the logarithm is a variable, that's when you have logarithmic equations. So write that down, make note of that, make sure you understand that once again. Like I say to you guys all the time, there are going to be plenty of times okay guys, sorry I'm back, I had to pause the video, but anyways, listen, I've told you many times in the future tests, where they're like big long semester tests, I'm going to mix all the equations together, so you have to be able to recognize when you have a logarithmic equation. I need to make some important comments that I think are important for you to write down. Here they are. Number 1, don't forget the argument of a logarithm cannot be negative or 0. Please don't forget that. The argument of a logarithm cannot be negative or 0. And here's a new property I've never mentioned before. The base of a logarithm cannot be negative. The base of a logarithm cannot be negative. So if I have this of 5, that is not possible. And you say, why? Well, to be honest with you, that's based on the definition of what a logarithm is. Logarithms are not made to be written to replace exponential expressions that have a negative base, and so you cannot have a negative base for a logarithm. Okay. All right. So with that in mind, here we go. All right. We will need to know both of those rules right here when solving logarithmic equations. Here are the steps. I would copy these down if I were you. Number 1, you always want to start off by isolating the logarithm. Number 2, after you have isolated the logarithm, you will want to write it exponentially. Number 3, then solve the equation. And number 4, check to make sure the argument or base is positive. Alright, so here we go. Number 1, isolate the logarithm. Number 2, write the expression exponentially. Number 3, solve the equation. Number 4, check to make sure the argument or the base, either one, is positive, okay? And so, write these down and let's use those. We're going to solve quite a few problems. We're going to solve 1, 2, 3, 4, 5, 6, 7 plus actually one page had 2, so about 8 of these, but relax, they go pretty fast, okay? Alright, Step one, isolate the logarithm. Now, watch what I'm going to do. I'm going to teach you to do this every problem. I'm going to circle the actual word, and I'm going to circle the argument. Everything else has to be taken away. Everything else has to go. This has to go, and this has to go. So, save the multiplying number for last. First, bring the 5 over and make it a negative 5. So now I have 2 natural logarithm of x equals negative 1. Next, get rid of the 2. The 2 is multiplying times the natural log. So we are going to divide both sides by 2. That leaves us with the natural log of x equals negative 1/2. Now students, I'm actually going to put negative 0.5. I don't mind you putting a decimal. When it terminates and doesn't repeat, that's fine. Now, is the logarithm isolated? Yes, we got rid of the 5, we got rid of the 2. So step 1 is completed. The logarithm is isolated. Now step 2, write the problem exponentially. Okay, what is my base right here? Even though you can't see it, it's a natural logarithm. E. So write this exponentially. Do you remember how to do that? The base always becomes the base of the right side here. And the argument stands by itself. So we're done. Step 3 says solve. Guys, we're done. Look at this. X equals e to the negative 0.5. So with your calculator, let me grab my calculator here if I can find it. So with my calculator, students, I'm going to type in my E button, and this pops up, and then type in negative 0.5, and then enter. I'm going to do that very quickly here. E button, negative 0.5, enter, and you'll get this right here. 0.607, I'm rounding, of course. Now, look at step 4, and don't ever forget to do this, please, students, because sometimes the answer is no solution. Sometimes the answer is no solution. Always make sure your argument or base is positive. So go back to this problem. Notice we have x right here in the argument. If I pick up 0.607 and put it right here for x, I would have natural log of what? 0.607, correct. If I put 0.607 right here, and for x right here, I would have this. And that's okay, right? My argument is what? Positive, so we're good. So this answer checks. But let's pretend my answer would have been negative 0.607. Well, when I pick that up and put it right here with the logarithm, negative 0.607, my argument is what? Negative. Thus, this answer cannot work. So the answer would be no solution. So you do have to always check your answers, guys, and make sure that whatever answer you get gives you out a positive argument or a positive base. Now in this case, my base did not have an x. My base had an e. So I didn't have to worry about checking my base, okay? But later on we're going to do some problems where your variable is in the base. And when that happens, you've got to make sure your base is not negative. Alright, let's try another one. Alright, here we go. Step 1, isolate the logarithm. I'm going to circle the word in the argument. So I have to get rid of this 2. Alright, so isolate the logarithm. Divide both sides by 2. And you're left with logarithm base 10 of 3x equals what? 2. 4 divided by 2. Step 2, write the problem exponentially. So 3x equals 10 to the second power, which is the same thing as 100. So 3x equals 100. Now divide both sides by 3, and you can write 33 and a third if you want. You can write 100 over 3 if you want, or you can write 33.3 repeating. That's totally up to you. But no matter what you pick, do you see your argument has an x? Step 4, we have to check and make sure our argument is going to be positive. So students, please watch this carefully. If I pick up, I have a positive 3 right here for my argument, right? In fact, let's just put the argument over here. What's your argument? 3x. If I put 33 in for x, or 33 and a third, whatever, if I take a positive number times a positive number, I get out a positive number, right? Well, that's good then, that this answer works. As long as my argument, which is 3x, comes out what? positive or not equal to 0, I'm okay. Alright, next problem. I'm working two of these. I want you to see the difference between these two. Do you see this problem here? This problem has parentheses around the 4x minus 1. Let me show you the difference between these, please, students. Let's start with this problem here. In this problem here, I'm going to circle the logarithm word. And I'm going to circle my argument. Negative 1 is not part of your argument. Over here, negative 1 is part of your argument because there's parentheses around it, thus pulling this together in one big group. Do you see the difference? Over here, I have to get rid of a 6 and a negative 1. So I'm going to first get rid of the negative 1. And now I'm left with 6. Natural logarithm of 4x equals 15. Now I'm going to divide both sides by 6. Natural logarithm of 4x equals, divided by 6, that would be 5 halves, or 2 1/2. Okay, next I'm going to write this. Well, first of all, step 1 is done now. I have totally and completely isolated my logarithm. Step 2, write it exponentially. Well, what's your base here, even though you can't see it? It's a natural logarithm, so e. So next I would have 4x equals e to the 2.5. Correct? Now, x is not by itself. Divide both sides by 4. Divide this side by 4, divide this side by 4, and you're left with e to the 2.5 power divided by 4. So how would you type that in? Well, I'm glad you asked. First, hit your E button, and this would pop up. And then type in 2.5, and then hit enter. Be sure and hit enter, okay? And then hit divided by 4, enter, and you'll get this right here. 3.046. Now, go to your argument. Everybody see the argument? What is your argument? 4x. 4x. If I pick this number up and put it in for x right here, I have a positive 4 times a positive 3.046. That gives me out a what? A positive number, so I'm okay. This answer checks. Now, compare this problem here we just did to this problem. Over here, when I tell you to do step 1, and I tell you to isolate the logarithm, circle the word, circle the argument. All that you have to get rid of is the 6. In this problem, we circled the word, we circled the argument, and we had two numbers to get rid of, a negative 1 and a 6. Because negative 1 is not part of your argument, but over here, negative 1 is part of your argument, so all you have to do here is divide both sides by 6, and you'll get natural logarithm 4x minus 1 equals 7 over 3. Now I'm not going to make that decimal because it's going to repeat, alright? So I'm going to leave it like this. 14 over 6 is 7/3. Now the logarithm is isolated, so write it exponentially. 4x minus 1 equals e to the 7/3. Guys, we're just getting started. Now get x by itself. Step 3 says solve the equation. So bring the 1 over and make it a positive 1. Now divide both sides by 4. So x equals e to the 7/3 power plus 1 all over 4. How would you type this in? Very simple. First of all, with your calculator, hit your E button so it looks like this, and then type in 7 divided by 3 and close the parentheses. So your E button, 7 divided by 3, and then hit enter, then hit plus 1, enter, and then hit divided by 4, enter, and you should get this for your answer, 2.828. Now if you're not getting that, your mistake is you probably forgot to put parentheses right here. It's e to the 7/3 power and close your parentheses. Now, students, do you see your argument right here? What is your argument? It's what? 4x minus 1, right? Isn't that your argument? So if I put a positive 2.8 in here, will I come out with a positive number? Of course I would. 4 times positive 2.8 is something like, I don't know, 11 point something. And then minus 1 is 10 point something. So when I put this number in for x right here, does my argument stay positive? Yes, it does. So this answer right here checks. Alright, let's try some more. Let's take a look at this one. Please copy that one down. Now, I have taught you to isolate the logarithm, correct? Well, which one do you isolate here? Well, these can get a little tricky, so if you'll listen to me, I'm going to explain this very well. Just listen to me. This one here, I noticed something special. I notice I only have a logarithm on this side, and I only have a logarithm on this side. Okay, that's all that I have. Now, compare that to the next problem we're going to solve. I have, actually, that's copied wrong. That should be a, that's supposed to be a minus or a plus. Okay, students, I'm back. There should be a plus sign right here, so fix that in your nose. But anyways, we're not copying this down yet, but compare this problem here, how we have a logarithm on one side, a logarithm on the other side, to this problem. We have a logarithm here and a logarithm here, and then another number over here. Do you see the difference? This problem here has only logarithms in it. This problem has logarithms plus a constant term. There's a little bit of a difference there, okay? Do you see the difference? Now, watch this carefully, please. Over here, if I've just got a logarithm on each side, no big deal, guys. Look, cross off the logarithms and just set the arguments equal to each other. You're allowed to do that, and that's really easy. So anytime you have a logarithmic equation with only one logarithm on one side and only one logarithm on the other side, cross off the logarithms and just set the arguments equal, and we're done. Bring the negative 1 over, make it positive. Bring the x over, make it negative x. 5 minus 1. 7 plus 1 is 8. Divide both sides by 4. X equals 2. Okay, now don't forget, you have two arguments to check. One argument is 5x minus 1, and the other argument is x plus 7. If I put a 2 right here, will I get out a positive number? Yes. If I put a 2 here, will I get out a positive number? Yes. So this checks. So for the third time, let's go over this again. If you have a problem in which you have just a logarithm on one side and just a logarithm on the other side, just cross off the logarithms and set them equal. And if there was a 2 right here, then pick up the 2 and put it right here like you're supposed to. And then cross off your logarithms, okay? So those there aren't too difficult, okay? They're really not. Don't let those freak you out and worry you. Logarithm here, just cross off the logarithms and set the arguments equal to each other. However, this next problem is different, okay? This next problem, we have two logarithms on one side, and then of course a constant term on the other side. And so we could try to move this logarithm over to get a logarithm on both sides, but if you do, look, it's a mess. Look what you have. It'd be 2 minus logarithm of x minus 1, and it's just not going to work. So here's what you need to do. You need to use your logarithmic properties. Remember how we've learned to condense logarithms. Sure, you remember that. I have a logarithm base 10, logarithm base 10, no number to the left, no number to the left, and they're adding. So we've learned when two logarithms are being added, you can write them as one logarithm, remember, as long as you do what to the arguments. Multiply them. 5x times what? X minus 1. Do you see that okay? Look at that, guys. That's not bad. Come on, look. If you have two logarithms on one side and they're being added, we've learned how to condense logarithms. We've learned how to expand them. We've learned how to condense them. We're condensing this down to one logarithm. And now we're looking pretty good. Now we have this logarithm of 5x squared minus 5, right? Isn't that right, students? Look, 5x times x, 5x squared. 5x times negative 1, negative 5x. There should be an x right there. And now we've isolated the logarithm right at exponents. There's a 10 right here. So I have 5x squared minus 5 So now I have 5x squared minus 5x equals 100. And now step 3 says solve the equation. Well guys, I have a quadratic equation. We know how to solve these. We definitely know how to solve these. Get one side equal to 0 and use the quadratic formula. And I've also taught you guys to reduce your quadratic equation. Make it smaller if you can. 5 goes into all these numbers. So shrink down your equation. Divide by 5, divide by 5, divide by 5, and 0 divided by 5 is 0. Now, I'm not going to take time and work out the quadratic, okay? You can do that on your own if you want to. Okay, I'm putting it up here so you can do it on your own. If you plugged all these numbers in, A is 1, B is negative 1, C is negative 20. If you plugged all those numbers in, you would get this out for your answer right here. You would get a positive 5 and a negative 4. Those would be your two answers, okay? Positive 5 and negative 4. That's what you would get from the quadratic formula. And feel free to work that out if you want to, okay? Now, here's the problem. I solved all this out. If I went too fast, back it up and watch it again. But remember what I've taught you. Step 4, check your answer. One of these doesn't work. What are your two arguments? One argument is 5x. The other argument is x minus 1. Negative 4 is not going to work. Negative 4 only has to fail in one of these. It fails in both of them. If you put a negative 4 here, you have a negative 20. It fails right there. Your argument cannot be negative. If you put a negative 4 here, negative 4, negative 1, it's a negative 5. It fails there. Negative 4 gives you out negative arguments. Now 5 is fine. If you put a 5 here for x, you get out a positive number. If you put a 5 in for x right here, you get out a positive number. So 5 works. So 5 is your answer. Back it up and watch again if you need to, guys, okay? Really important you understand this. Alright, next we have 2 more and we're finished. Okay, step 1, isolate the logarithm. I'm not sure here. Let me look at something here. Okay, and here. Guys, I don't know why I'm making so many mistakes on my typos tonight. That should be an X right here. Sorry about that, okay? Alright, there we go. That should be an X. Alright, here we go. Step 1, isolate the logarithm. Well, the logarithm's isolated. Here's my word. Here's my argument, so it's isolated. Step 2 says to write the problem exponentially. Well, that would be 256 equals 2 to the what power? X. Now, step 3 says solve the equation. Well, guys, we know how to solve these. I want to write both sides with the same base. So, 2 to the 8th power, don't forget, equals 256. So in place of 256, I can put 2 to the 8th power equals 2 to the x. Well, obviously 2 to the 8th equals 2 to the 8th, so x has to be 8. So the answer is 8. Now, you don't have to check your argument. There's no x. You don't have to check your base. There's no x. So the answer is 8. Last but not least, here we go. Okay, step number 1 is isolate the logarithm. It's isolated. Here's your word. Here's your argument. Step 2, write it exponentially. So I would have 343 to the r equals x to the 3rd power. Okay, so there is the problem written exponentially. Alright, now step 3, solve the equation. Guys, we know how to solve equations that have a 3rd degree or x to the 3rd power. I take the cubed root of it, we know that. If I want to get x cubed down to x, I take the cubed root of it. However, if I take the cubed root of one side, I must take the cubed root of the other side. Now, yes or no, do I put a plus minus? Well, you put plus minus when 2 things happen. Number 1, you insert the radical. So, did that happen? Yes, that happened. You insert the radical. Here's the radical right here, right there. We chose to put it in. That was not there in the original problem. But there has to be something else too, though. Both of these have to exist. If index has to be what? Do you remember? Even. And your index is what? Odd. So no, you do not put plus minus. Both of these scenarios have to be true, and this one here was not. Did you insert the radical? Yes, you did. But was the index even? No, it's not. So here we go. The cube root of x cubed is x, and the cube root of 343 would be, I believe, 7. 7 times 7 is 49, and 49 times 7, 63, 28, yep, 343. So, 7 times 7 times 7 is 343, so the cube root of 343 is 7. Now, if you've forgotten how to do that, if you'll hit math on your calculator, I think it's option 4. I'm trying to locate my calculator here. Option 4 should be a cubed root. So you hit math, option 4, a cubed root pops up, and then type in 343, and you'll get out 7. Now, do we have an x in the argument? No, but do we have an x in the base? Yes. So the 7, if you put a 7 in for x right here, is your base still positive? Yes, it is. So we're good. The answer does check. You must always have a positive base and a positive argument. Guys, I hope this video has been a help to you. If you have any questions, please never hesitate to call or email.